Okay, welcome back. Like I said, it is week 2, lecture 1, and this is actually a really cool section. It starts a little, I shouldn't say confusing, but there's some interesting definitions here, and I will be sure to tell you what ones you need to know for your test. Remember, you'll have a test um, around week 7 or 8, so around the middle of the semester, in middle of October, we will be doing a test on this stuff. So I will be sure to tell you what to know. Um, well, actually, speaking of that, I mean, this right away is something you guys should definitely know. And more specifically, you should know the differences between the 4 basic types of hydrocarbons. Hydrocarbons are crazy complicated molecules. I mean, well, they can be simple, like propane or ethane, but you can have crazy complicated hydrocarbons. Like I think in chapter 5 we'll talk about PAHs, polyaromatic hydrocarbons, multiple rings, multiple functional groups. But the basic types, and specifically in this course, the basic types are alkanes, alkenes, alkynes, and aromatics. And I know, or I hope, that in Chemistry 1121, you did a little bit of material in alkanes, alkenes, and alkynes. If you didn't, or if you can't remember, it's not a big deal. I think I have a picture. Yeah, okay, I have a picture coming up that explains the differences between them. So I'll kind of get into what each of these are in a couple of minutes. So in organic chemistry, hydrocarbons are divided into 2 classes. So these basic types can be split into 2 classes. There are aromatic compounds and aliphatic compounds. So aromatic are, I want to say ring-based, but they have an aromatic ring in them. An aromatic or benzene ring is different than a normal ring, and I will talk about that soon, like in the next couple slides. Aliphatic can be straight chains. They can be cyclic. That's a very poor cyclopentane. But they don't have this. This is called a benzene ring, which I'm going to talk about today. I'll talk about in chapter 4 a lot. So we'll get to see these today and in the future. You can have crazy hydrocarbons with like branches and all sorts of things. So anyways, so aliphatic, aromatic. Aliphatic hydrocarbons, these are your they can be ring-shaped or straight chain, but they are not benzene. That's the key. So this would be cyclic right here, but they are not benzene. This is something, I'm underlining this right now. These are terms that you will need to know by the time we get to chapter 2 and chapter 3. The term saturated and unsaturated, we will look at this more in chapters 2 and 3. But if any of you are interested in diet or nutrition or food, you might have heard the term, saturated fats, unsaturated fats. These are hydrocarbons, and saturated means single bonds, and you can kind of use that S to help you remember this. Saturated, single, saturated, single. From my limited knowledge in English, I would never say I'm an English master, even though it is my first language, arguably my only language because I don't remember much French. Single or saturated, sorry, what I mean is when you say something is saturated, it's like completely coated or completely dissolved. And the way I like to think about it is a saturated compound is single bonds, meaning it has maximum possible hydrogens. And we'll talk more about that in chapter 2 and 3. So don't really worry about this for right now. Unsaturated have double or triple bonds, meaning they don't have full hydrogen amounts. So, simple summary of this is aliphatic compounds. These are single, double, or triple bonds. They can be rings, but they cannot be a benzene ring. So basically, anything that's not a benzene ring, any hydrocarbon that doesn't have a benzene ring, we would call aliphatic. Anything that has a benzene ring would be called aromatic. This ring I will draw again here. It's a six-sided or six carbon ring, and it has alternating double bonds. So every second carbon, or like every second bond would have a double bond. So this is a benzene ring, and sometimes people write it like this. If you've ever done this before, you might have seen it with a circle in the middle. And I can explain what the circle means, but it might be better to come back to this in chapter 4. Let me just see, I have a chat. So, okay, so someone else, Niam, has mentioned they've seen this stuff in biology, which you definitely would hear about a lot of this stuff in biology. Maybe not physics, but certainly chemistry, biology, nutrition, if you've ever done a nutrition course. Let me just read the crazy definition for aromatics. You'll see an aromatic ring in 3 dimensions in this course. I have software that I can use to show you what the ring, actually I could do that now maybe, show you what the ring looks like. But aromatic compounds are very special. They are ring shaped, they are flat. A lot of hydrocarbons are not flat. They are, I hate saying 3D, but they're kind of in the XYZ axis. They're the molecules, the bonds, the atoms, they're kind of going in all not in all directions, but they're sticking away from each other. So like methane would be a 3D type of shape. It's a tetrahedral is what you learned in chemistry 1120, if you can remember that. But aromatics are so amazing because of their stability. And I am going to maybe I feel, I should look this up, but I feel the word aromatic comes from the fact that a lot of these molecules are very aromatic, and that word means they have a distinct odor or smell. A lot of them smell fruity or minty or sweet. A lot of things that you guys cook with, a lot of chemicals that are in foods like vanilla and cinnamon. Well, cinnamon I think is an aldehyde, but the smell, I mean, but a lot of scented molecules that have a very nice, strong odor, they are aromatics. So I'm going to assume that's where it comes from. They really smell good. And they can, and Niam asked the question, can they be stinky? Absolutely. Some of them can smell really bad or pungent, or, I mean, smell is subjective, but some of them can really kind of stink as well. But from me, I'm really interested in food and food science, and I know a lot of herbs and smells, natural smelling items, like minty items or citrusy items, molecules, they can have aromatic compounds in them. I'm really tempted to show you this in 3D. I kind of want to show you guys a cool website, so maybe I will. Just give me 1 second here. I will share a new screen here for 1 second. This is a really, really cool website I'm going to share for you. And this website is moleview.org, and aroma definitely refers to good smell, but I think if you looked up aromatic, or at least in chemistry, the smell can definitely range. But aromatic compounds would have a very strong smell typically. Okay, so this is a really cool website, moleview.org. I think you could see the address up there in my Google Chrome. Really cool. I used to use it before I had proper chemistry software. because this is free, but I have for you guys, I purchased a really nice piece of software. Let me make a simpler chain here. Let's do something shorter. Let's do 4 carbons here. So we'll do butane. This is butane with the hydrogens. I'll clean it up, make it look nice and big. So this is butane. And if I click on the top, this 2D to 3D button, takes a second. And this is what I mean when I say the molecule is in 3D. It's not necessarily flat. You can see the chain goes up and down, and you can more specifically see that the hydrogens are sticking off on like separate axes, different angles. So this would be like a 3D molecule. Okay, an aromatic, and like if you look over on the left of the screen, aromatics have their own button. They're so important. They have their own button. So here's an aromatic. Here's a benzene ring, I should say. I'll turn it into 3D. And you can see that this molecule is flat. Okay, everything is on like the same axis or plane. There's nothing sticking up from this or away. Like it's flat. It looks like a flat disc, like a frisbee or a plate. It's flat. So there's benzene. And the fact that it's flat and the fact that it has double bonds alternating gives it really cool special properties. So anyways, if you guys are ever bored or you're doing an assignment and you want to see, well, let me just show you how cool this is. I mean, you're doing an assignment and you have a really complicated chemical and you want to get the name of the chemical. You can click, I got to maximize my screen here. Sorry. You can click up top tools and you can look at the information card and it will generate an information card about this molecule, including, probably shouldn't be showing you this, but anyways, here I am showing you the name. This is our IUPAC or systematic name. I will warn you that this is not perfect, but it does give our systematic or IUPAC name. It's not always 100%, but it does give us the name of the molecule. So you can draw all sorts of different molecules and it'll give you the name, right? So let me just show you again. I'll draw another one. I'll clear my screen. Let's make cyclo and let's put a couple methyl groups on that. And I'll go to tools, information card, 1,2-dimethylcyclopentane. There you go. And there's a really, really tiny picture over here on the left. I don't know why they don't make the pictures bigger. But I mean, this goes for you in any your capstone projects, any research that you guys are doing, any assignments you're doing for me. You can use this site to generate names, get the molar mass, all sorts of things. Really, really cool. And it is kind of fun to mess around with. All right, back to my notes. I'm almost done, by the way, guys. I know I haven't done much today, but it's been a day. It's been quite the day. All right, so benzene ring. Benzene ring, we will do more of this in chapter 4. I'm not going to get into this too much today, but these rings can move. The double bonds can move. And it's kind of like, you know, you're thinking right now, this is actually the perfect time to talk about this.
So we can't see the notes.
Oh, sorry. Thank you. I'm dumb.
Yeah. No, it's okay.
Sorry. Thank you for that. I guess that's a good reason for me to leave your mics on so you can tell me. I hope you can see the notes. This benzene ring structure, the double bonds can actually switch places and move around the molecule. And this is really technical reason on why benzene is so stable. It has something called resonance, which we will do in chapter 4. I'm not going to spend any time today. And I mean, we don't need to get into this in chapter 1. But like, think about social distancing. One of these bonds, double bonds, decides to move to the bond next to it. Well, the other double bond says, hey, man, social distancing, get away from me. So he moves to the next bond. Then this bond, same thing, get away from me. We got to stay 6 feet apart. So he moves to the other bond. And we end up getting this structure over here. Like they go back and forth, back and forth. They are the exact same chemical. There's no changes in the chemical. But the fact that the bonds can move and move and move, a lot of people draw benzene with a circle in the middle to show that the double bonds are moving around. It's called resonance, and it's the reason why benzene rings are stable. They're not as reactive as alkenes. And some of you might be thinking, well, yeah, isn't it just an alkene? It's just double bonds. But the fact that there's 3 of them creates stability because the bonds can move within the molecule. I'm going on way too long because this is in chapter 4, but it's really cool. I would never say these molecules are like living creatures, but like they have like, they're not as stable or stable as you think they are. In all, many molecules, bonds are forming, radicals are forming, ions are forming. It's like this equilibrium you learned about in 1121. Anyways, this is the summary of the 4 that you need to know. Wink, wink, wink. I might ask you, I might draw a molecule on your test, and I might say, is this molecule an alkane, an alkene, an alkyne, or an aromatic? So alkanes, single bonds. I see a message in the chat. I'll get to that in 1 second. Alkenes, double bonds. Alkynes, triple bonds. And then aromatics or benzenes, well, they have that ring. I don't want to say ring though. It has to be a benzene ring. Okay, it can't just be a circle or a cyclic chemical. I just had a question, are some of these like viruses? I didn't mean to say they're living like bacteria or viruses, but they certainly make up, these chemicals make up bacteria and viruses. I just wanted to say living because like, if you look at a glass of water, pure chemical water, it's H2O, but within that glass of water, things are actually happening. The water molecules are self-ionizing, so they turn into different ions. So, what I didn't mean they were living like a virus. I just meant to say like, the molecules aren't just staying like you think they are. They're vibrating, that they're rotating, bonds are switching, and again, ions are being formed sometimes. And it's all about, equilibrium. These reactions happen, but they're going forwards and backwards and forwards and backwards. All right, I think it's almost 4. What do I want to do? Okay, this is perfect. I want to give you a couple more definitions, 3 more definitions, and then I'm going to leave it at functional groups. We'll do functional groups tomorrow. Tomorrow, a really important class to come to. I'll talk more about it tomorrow, but I have good news about functional groups. I'll mention it maybe at the end of class, but let's just do 2 more slides and you guys are free and done for today, I hope. I really hope you don't have class after this. That'd be a long day. So this is also in your course outline, and there are many ways to classify organic compounds. Think about classifying humans. Like me, you could classify me as many things, male, Caucasian, Canadian, Newfoundland, expat. I mean, there's so many ways you could describe me, so many ways. Brunette, right? Brown eyes. And organic compounds are the same. You can classify them based on lots of different properties. You could classify an organic compound based on its functional groups. So, you know, some things are alcohols, some things are ethers, some things are carboxylic acids. You could classify them by double bonds. You could classify them in so many ways. And these are three others that you are expected to know. Wink, wink, you might need to answer a multiple choice on this. So let me explain. Chemical clown, I like that. I think I like chemical clown versus chemical genius for myself anyways. But these are the three definitions that you need to know. And the reason I'm stressing this is every year I put this question on the first test, and every year, even on the final exam, somebody in class puts their hand up and they say, I've never heard of this. And then I say, you did, or it's in your notes. So there's 12 of you here out of 14. So I hope none of you are surprised when you see slide 29 on your test. And basically what I'll do, and I'm blatantly telling you this, which I normally don't, but I'm so tired of the question. I'll just give you a definition, explain the type of compound, and I want you to tell me, is it acyclic, carbocyclic, or heterocyclic? And again, what do those words mean? It's pretty easy. Acyclic means a compound that is not cyclic, not a ring. The letter A before a word in English usually means like it's the opposite. Like there's a show on Netflix, I think it's called Atypical, and I think I've only seen it once or twice, but I think it's about a boy who doesn't feel normal. He's atypical. I think he has mild autism or something. Atypical means it's not typical, not normal. I shouldn't say normal, that's really rude, but not what you would think. So acyclic is not cyclic. Okay, so whenever you see that in English, like atypical, that means that the letter A means it's like the opposite. So acyclic, not cyclic. So a hydrocarbon, that's not a ring. Cyclic meaning ring. Carbocyclic compounds are any group of organic chemical compounds in which the atoms are carbon atoms. So again, like break this down into English. Acyclic, not cyclic. Carbocyclic, it's a cyclic compound, a circular compound. Like circular is a bad thing to say, but a ring. Okay, that's cyclohexane, cyclopentane. Cyclopropane is fun because it's just a little triangle. I don't think it's very stable. Even benzene counts, so I could draw this as benzene. But every bond, every atom in the chain is a carbon. Hydrogen doesn't count, of course. Heterocyclic, so again, when you hear the word hetero in English, you learned about this in chemistry. Heterogeneous versus homogeneous. Hetero means different. So heterocyclic means it has a ring, but some of its elements are not carbon. Okay, so there's lots of examples of this. Most of them that I see in common chemical compounds have nitrogen in them. So it would be like a ring that has nitrogen in it, maybe oxygen in it. Okay, I drew that really horribly, but you get the idea. So let me just say this again in summary. Acyclic, no ring. Carbocyclic, a ring with only carbons. Heterocyclic, a ring with carbons and other atoms. Or it doesn't need to be carbon, but it would be like carbon and nitrogen, nitrogen, oxygen. Two different elements are in that ring. So you will see that. There's 12 of you. I'm going to have this on recorded history on YouTube. So when somebody in the first test says, we never learned this, or I don't remember this, I will pull up week 2, lecture number 1, skip to the end, and I will say, you definitely heard about this. All right, cool. So guys, that was a pretty minimal lecture today, but I think that's enough. So I'm going to hit stop record, and I will open up the floor or the chat to any questions you may have.